Right, hello everyone, and welcome back to another video. This is Zong, and today we'll be doing exercise 1D of the IB HL Analysis and Approaches textbook from Oxford. Last video didn't have any audio because I was tired and did not want to record any audio, but hopefully it still helped otherwise. So let's go ahead and get started. Question one is telling us that in 2010, shop sold 220 televisions. Every 6 months, the shop sold five more televisions, so that it sold 230 televisions in 2011 and 240 in 2012, etc. So 1A is asking us to evaluate how many televisions the shop sold in 2017. Since we know that at first they sold 200 televisions in 2010, and each year, well, actually it says each 6 months the shop sells five more TVs, and we can just multiply that by two so we can get a year. So in 1 year, the shop would sell 10 TVs. So ignore that. So we can just do plus 10T. And if we plug T into like 1, 2, or 3, that'll evaluate the year. So we're going to plug T or 7 for T. So then we get 220 plus 10, 7, which is going to be equal to 290 televisions sold in 2017. Let's continue. 1B. Calculate the total number of televisions sold between 2010 and 2017 inclusive. Remember, inclusive includes both 2010 and 2017. Exclusive would just be the numbers in between those. But for this, we're going to have to call back to our summation formula for arithmetic, which is just going to be n divided by 2 times u1 plus un. In this case, our u1 is going to be our U1 is going to be 220 because that's for 2010, and then our last year is asking us for 2017, and we know it sold 290 TVs in 2017. Here our n is actually going to be 8, and the reason for this is because in the arithmetic right here, remember, this is how it's actually set up. And for this to be 7, n needs to equal 8. So just remember that. But yeah, we plug all this in. 8 divided by 2 times 220 plus 290, and that is equal to 2,040 televisions sold in that period of time. Next is going to be 1C. The selling price of a television was £600, I think that's pounds, in 2010, but the selling price fell by $20 each year. In a particular year, the number of televisions sold by the shop was half of the selling price of each television. Determine in which year this occurred. All right, so a bit confusing at first. Let's go back at what it's telling us. We know that at first they were selling TVs for £600, but after or each year after that, it fell by £20. So the price after a year T is going to be equal to 600 minus 20T. And what it's asking us to do is to, find a year where television sold by the shop was half of the selling price of each television. We know that the selling price of each television for any given year is given by this formula. And since it's saying, what's that? Since it's saying was half of the selling price, that means that we just put this equation back in here. And we get something that looks like this. Okay. This is equal to, well, I should do that. This is equal to 300 minus 10T. Scrolling down. Did I do this right? Yes, I did. Okay. And that means that 20T is going to be equal to, oh, whoa, 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 whoa. I see what I did wrong. Okay. That's not the equation for how much a TV is. It's 10T, 10T. Okay. 20T. Okay, secret. Now this all works. Okay, let me just fix this real quick. Erase all this. Okay, here we go. This means that 220 plus 10T is going to be equal to 300 minus 10t. This means that 20t is equal to 80. T is equal to 4. That means 4 years have passed. So that means 2010 plus 4. So this occurs in 2014. Just like that. Sorry about that. That's what happens when you start to go fast and miss all your equations, blah, blah, blah. But I do got to go fast today. All right. Two is saying that Jane started working in 2000. On each successive year, she received a salary increase equivalent to 1.5% of her previous salary. In 2011, her salary was 49,650. Determine the starting salary to the nearest pound. Okay, I don't know why it's saying that, but let's just continue. So we know that in 2011, or her wage for 2011 is going to just be equal to her wage in 2010. Sum of 20. Oh, well, I shouldn't write it like that. Sum of the first year, which is 2010, times 1 point. Oh wait, no, the sum of the first year is 2000. Sorry. So I'll write it like that, so it makes more sense. Times 1.015 to the 11, because it's been 11 years since then. And that is equal to, what was it? 49,650. Okay, that means that her wage or her sum in 2000 is going to be equal to this 49,650 divided by 1.015 to the 11th, and that is around 42,150 to the nearest euro. Oh, that's euros. Just just came back to my brain. But yeah, that was a bit confusing. All we did was let her wage equal her starting wage times the R value here, which is equal to that. Then we divided, and we got her wage in 2000. Okay, number 3. Carla traced her family tree back 4 generations. Carla's parents are the first generation back, and her first set of ancestors. Carla's 4 grandparents are the second generation back, and her second set of ancestors. 3A asks us how many ancestors are in Carla's family tree. Okay, so as you all know, this is just assuming that everyone doesn't marry someone that they're related to, blah blah blah. You know how history is. But since each generation back is going to have 2 to the power of, let's just say, k people for 4 generations. Yes, Carla's 4 grandparents, second sense. Okay, so for 4 generations, we can get the sum of this for the 4 generations. And that's just simply equal to 2 to the 1 plus 2 to the 2, 2 to the 3, and 2 to the 4, which is just equal to 30. That's not a 24. So the answer is 30 ancestors. 3B. Determine how many generations back she would have to trace to find more than 1 million ancestors. Okay, so here we're going to have to create a summation where k is going to be equal to 1, aka her parents, and n is going to be the number up here that we're trying to solve. And we know that sum of this, 2k, okay, and we're trying to find when this ends up being greater than 1 million. Okay, easy enough. First thing we're going to do here is set this back. Let's find more than 1 million ancestors. Okay, we're going to set this equal to 2 to the n plus 1 minus 2. And remember, the reason why this works is from the exercise, not the exercise earlier on, but what it gave us in the textbook, or this is just equal to that, the summation of this. It's just a fact. I won't explain it right now, but let's continue. All we have to do now is solve for, no, that's not, okay, solve for this. So we're going to plus 2 on both sides. And then with a calculator, we'd have to take the log of both sides. Plus 1. That's around, according to my calculator, 21. No. 20. 20. So that means that n has to be greater than 19. That is our solution. Question 4. Whoa, this is a long one. Okay. Prasanna is testing a recipe for a cake and tries it out several times, adjusting the amount of flour and sugar she uses each time. In the first recipe, she uses 200 grams of flour, and she decides to increase the weight of flour by 20 grams in a trial. She has time to try out the recipe just 10 times. How many kg of flour would she need? Oh, there's more. She has 1.5 kilograms of sugar available and knows that the amount of sugar needed is usually half the amount of flour by weight. After the first 2 trials, she decides to change the amount of sugar in each trial according to the geometric sequence. Okay, so it's geometric. Evaluate the number of trials it would allow her to carry out. Explain how reliable her model is for using a geometric growth, or explain how reliable her model is for using a geometric growth model for sugar content. Whoa, okay, it's a bit confusing, but it's fine. Let's start with what we already know. Looks like it's asking us 2 questions here. So part 1 is how many kgs of flour she will need. This is going to end up just being an arithmetic sequence. So let's write everything down. We know here that U1 is going to be equal to 200 grams. So that's how much she's starting with. And for each trial, she loses 20 grams of flour. So our difference, oh, sorry. For each trial, she has to increase the weight by 20 grams. So our difference is going to be 20. And she has a max of 10 trials that she can have. Okay, and it's asking us how many kilograms of flour she would need to actually do all these trials. So since it's just an arithmetic, we can do our summation thing from earlier, and we can start plugging in the numbers. You actually don't need to find what UN is equal to here. We can just plug in what the formula for UN is. So summation up to 10 is going to equal to 10 divided by 2. You want 200 grams flour plus 200. So this is where the formula starts to come in. Plus D, which is 20, and minus 1, so 10 minus 1. And after doing all the math for that, you should get 2,900, and that is in grams, but it's asking us for kilograms. So remember kilograms, 100, go back 3 decimal places, 2.9 kilograms. That's our answer. And then there's another follow-up for the sugar, or the sugar question it's asking us for. It says that she has 1.5 kilograms of sugar available. So 1.5 kilograms is equal to 1,500 grams. The amount of sugar needed is usually half the amount of flour. After the first 2 trials, she decided to change the sugar in each of the trials according to a geometric sequence. So let's get started. Let's mark these as trial 1. In trial 1, she has 200 grams of flour, which is 100 grams of sugar according to her. Trial 2. See what we're doing here. If there's any background noise, I apologize. But if you see what we're doing here, 220 grams, I'm going to mark that as flour and sugar. Now, flour is going to be 110 grams of sugar. And since it's going to keep increasing like this, 230 grams or 240, 120, said it's geometric. So we can't just do addition here. We actually have to create a common ratio. So let's create that ratio. It's going to be trial 2 divided by trial 1, which is equal to 110 grams of sugar divided by 100 grams of sugar, which is 1.1. And that is our common ratio here. But that's not all we need to do. We need to evaluate how many trials we can actually do if we only have 1500 grams of sugar. And to do that, we have to find the biggest R that we have. So let's set something up right here. And it starts with 100 grams of sugar. And this is our little equation here. We need to find the sum of all this by creating summation right here. And remember our geometric summation is going to start with our Q1 here times 1 minus R to the n, which is 1.1 here, 1 plus 1.1, which is our ratio. Okay, and that's equal to, well, doesn't have to be equal to. Let me put that back. It's just to be less than or equal to 1500. After doing the math here, divide by 100 and multiply by your numerator, you get n to be less than or equal to around 9. So that is your answer. So you can carry out 9 trials before all this happens. Oh, there's more to that. Says explain how reliable home model is for using a geometric growth model for sugar content. This realistically wouldn't be reliable. Uh, I don't know where she's getting these proportions from. She even says usually, and it's not even geometrically. I mean, imagine this geometrically grows in real life. Imagine how much sugar you would end up actually needing at a certain point. So yeah, for long sequences, or if you're trying to make, a bunch of trials, it's just not going to work. So that's your answer to that. Question 5 gets super tricky. I remember doing this back in the day. Um, didn't really make any sense to me, but I've got it figured out by now. It says the first diagram shows a sequence of squares. Starting with the largest square, the midpoints are joined to form Oh, I lost my point. The midpoints are joined to form the second square of the sequence. This process can be continued infinitely in theory, but not in practice. Yeah, we don't care about that. So let's go ahead and get the side lengths. I'm going to attempt to draw this out just so you can get like the gist of it. I'm not an artist by any means, so it's okay. This should be good enough. Okay. And there's more that I need to actually read that's on the other page. So 5a says that the sides of the largest square have lengths of 2 units of the entire type to calculate the side lengths of the second, third, and fourth squares. Now, luckily, there's actually a way to do this mathematically without having me to like draw this. But we know that side 1 is going to be equal to 2. Side 2, side 2 is going to be 2 divided by the square root of 2, which is equal to the square root of 2. And the reason why this is the square root of 2, I should actually explain this. Sorry. Reason why this ends up becoming the square root of 2 is because this is a triangle. So if this side is 1, this side is 1. 45, 45. This is equal to the square root of 2. So yeah, my apologies. I should explain that beforehand. That's going to be side 2. And then this pattern just continues. Side 3 is going to be equal to the square root of 2 divided by the square root of 2, which is equal to 1. Side 4 is going to be equal to 1 divided by the square root of 2. And I guess we gotta rationalize this. Square root of 2 over 2. And that is your answer for 5A. 5B. 5B says, use our answers from part A to find the length of the spiral shown. Okay, so I actually got to go back to this other page. Okay. So it's asking us to find the length. This should be fine. I'm not going to draw it too well here once again from last time, but you should have this paper with you. The spiral only goes down to the first 4 squares. So it's looking at here, then here, here, whoa, and here. But that's not important. We just need to know that it's the first 4 squares that it's showing us. That means that the spiral length is going to be the side length of 1 plus one of the side lengths of 2, then 3, then 4. And from earlier, we know this. This is just going to be equal to 2, square root of 2 is 1, plus square root of 2 over 2. And rounding to the nearest 3 significant figures, you get 5.12. But for D, this time we're trying to find the total area of the shaded regions. Now, each of these shaded regions is actually going to be just a side onto the midpoint. I don't have the image on here, but you all have it, so you can see it a bit more uh, easier than me. Remember that the area, these are all triangles, by the way. So remember that the area is going to be equal to 1/2 base times height. Now, if you count precisely, there's 8 triangles here. Remember that each time the sine length is going to be basically just divided by the square root of 2 for each of these. So it just keeps on getting smaller and smaller. So our area is going to be equal to 1/2. And then here we set up this huge equation. First, we have 1 squared, because that's our base and our height. Since these are all equilateral triangles, we can just square our base, and that also gives us our height. The triangle following that has a side length of 1 divided by the square root of 2. Remember, that's all squared. And then the next triangle following is going to look like this, and so on and so forth, all the way up until we get to the 8th triangle, which is this. Now, it'd be horrible to even like try to do this by hand. So instead, we're just gonna write it out a bit more simply, only using a couple of terms. That becomes 1 plus 1/2 plus 1/4 dot 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 1 divided by 2 to the 7th. Okay. Now here we actually have a little series going on. So we can use our equation from earlier, the summation of a geometric series, which is going to be equal to 1/2, which is the triangle. This isn't usually included in it, but this time it will be u1 times 1 minus the ratio, which in this case is 1/2, to the power of how many terms we have, and in this case it's 8 terms, or 8 triangles, divided by 1 minus 1/2, which is equal to 1 minus 1/2 to the 8th, which is approximately 0.99666. That is your answer. This one, oh, this problem is confusing, but it should be fine. Now 5e is asking us to determine the total area of spirals, or determine the total area of the spiral form if the process of forming squares and shading triangles is continued infinitely. Okay, well, this one's actually a bit easier since we know it's going to be a summation of infinity terms. Remember that 1/2 is in there for the triangle. We already have everything from last time. You know, u1 is going to be equal to 1, r is going to be equal to 1/2. And remember our summation for infinite term is just going to be u1, 1 minus r. So we have 1, 1 minus 1/2, and this is equal to 1. Beautiful. Okay, zoom in a bit. Hold up, gotta read this whole thing. 6a says that Guhun takes out a loan of $1,500 to furnish his new student apartment. The terms of the loan are that Gihun will pay equal monthly installments. Interest is calculated monthly and is to be charged at 12 pure PA, which here just says it means pure annual, which is just each year. And the loan is to be repaid in 2 years. 6a says to calculate the amount that Gihun has to pay each month if the first repayment is made 1 month after the money is borrowed and after interest is calculated. Jeez, I hate this unit. Okay. Remember that our original loan is going to be $1,500. So let's write that down. You know, there's an annual interest rate of 12%, which is a monthly rate of 0.01, which is 1% per month. And since it's 2 years, number of months are going to be equal to 2 times 12, which is equal to 24. And the only reason I'm converting this into months is because 6a actually asks us for each month. That means the amount after 1 month, or the amount due after 1 month is going to be equal to 1,500 times 1.01 cents, remember, 1% interest a month, minus X, which is just however much he's paid off. We don't know that yet. After 2 months, it's going to be exact same thing times 1,500 times 1 point, these should all be multiplied, sorry, squared, minus however much he paid off, the first one, minus 1.01 x, and that's how much he's basically paid. That's also multiplication. Okay, I'm not going to write the rest of it, but just know that after 24 months, we get the same equation going on. Get 1,500 original installments times 1.01, power of 24, which is the amount of months, minus however much he's already paid, 1.01 to the 23x, dot, 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 minus x, and that should all equal to 0 at the end. Okay, it's gonna be a bit hard to see at first, but what we can do is actually take out an x from each of these terms. So bringing this over here, we keep our original how much he owes. We take out an x from everything in here. This is basically a geometric sequence. So we minus it by x. Now we just have this. Dot 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 minus, or well, I guess it'd be plus 1 in these cases, which is equal to 0. And this is a geometric sequence. Sum of a geometric sequence is given by u1 yeah, hold on. I'm getting lost over here. u1 points 1 to the 24, which is our un, minus 1, and then our ratio 1.01 minus 1. 1.01 is our ratio in all of this, I should say. And I'll take the u1 out there and we'll just replace it with x. Okay, so we can slide all of this down here now. So we know that 1500 times 1.01 to the 24 minus x, 1 to the 24 minus 1, divided by 1.01 minus 1 is equal to 0. And then adding x to both sides and getting rid of the fraction, we get 1500 1.01 to the 24 is equal to 100x power. Now we divide by 100 on both sides. And divide each side by 1.01 to the 24 minus 1, and that gets us our x value. Using technology, we figure out that x is equal to 70.6, which is the amount he has to pay a month. That is our answer. That was definitely a bit confusing, but it's fine. Jeez. Okay, on to 6b. Evaluate how much to the nearest dollar Giyun actually has to pay for furnishing the apartment. Okay. Since the monthly payment is gotta come out to 70.6 for each month, we're just gonna multiply that by 24. I shouldn't write it like that. 6b, take our monthly payment, multiply by 24 months to get 2 years, and that's going to get you equal to 1,695. That's rounded. And that is our final answer. Okay, on to 7. The cinema front row has 30 seats. Each next row has 6 more seats than the one before. We need enough rows to reach 570 seats. Then we'll compute the distance to the back row and the ceiling heights. So first we have to evaluate how many rows the cinema should hold. Okay, let's get started. The seats per row form an arithmetic sequence, since it's just going to be plus 6 seats, plus 6 seats for each row that we have. There are U1 is going to be 30, and then our difference is going to be 6, and the number, or n is going to be equal to the number of rows you have. And it's saying in total there are 570 seats, so 570 is going to be equal to the sum of all these rows, which for an arithmetic sequence is given through this. It's gonna be 2. Well, I should do it like this. It's going to be U1 30 plus UN, which is 30 plus 6 and minus 1. And then solving this, we get that n times 60 plus 6n minus 6 is equal to 1,400. And from here, you create a quadratic equation and then simplify it all. N times 6n plus 54 is equal to 1140. 6n squared plus 54n minus 1040 is equal to 0. We can divide each side by 6 in order to get n squared plus 9n minus 190 is equal to 0. Factoring it out, we get n minus 10, n plus 19. Since we can't have negative rows, we know that n is going to be equal to 10, and that is the 7b time. For optimum viewing, the floor of the cinema needs to be stepped. So the step between each row is 50 centimeters high and 95 centimeters deep. Assuming that the front row is 3 meters away from the screen and the ceiling is 2.4 meters above the last step, determine the horizontal distance from the screen to the top row, the maximum height of the ceiling, assuming that it is not slanted. Okay, well that's C. But so now we're just figuring out the horizontal distance from the screen to the top row. Jeez, this is confusing. Okay, you know that the front row is centered 3 meters away from the screen, so we can start with that. This is the front row. That's 3 meters away from the screen. And then each other row goes back, what was it? 95 centimeters, which is 0.95 centimeters, or 0.95 meters. So each row goes back 0.95 meters. We'll use meters for now. So figure out the distance to the back, which is just all the way to the top row. We can use this formula here, 3 plus, and, oh, let me not write it like that. It's arithmetic, so let's write it in our usual form. 3 plus 0.95 and minus 1. We know there is 10 rows, so that means that get this formula, 3 plus 9 times 0.95, which is then going to be equal to 11.55 meters. And that is our answer for how far the horizontal distance is from the top row of the screen. Next is the height. Is it 7? Yes, 7. We know that each row rises by 0.15 meters, which is 15 centimeters from the equation. That means that once again we get a arithmetic sequence where the first row is at 0, or yeah, it's at 0, so 0 plus 0.15 and minus 1. Once again, we know there's 10 rows, so we get 9 times 0.15 is going to be equal to the height, which is 1.35 meters. However, that only gives us the height up to the seats. We still need to include the actual ceiling heights. So to do that, just do 1.35 meters plus 2.4 meters, which is equal to 3.75 meters high. That is our answer. Okay, Number 8. Gotta get through this a bit fast. Oh my God, this is long. Okay. Isla, Brianna, and Cindy each received 200 euros from their parents with the condition that they must promise to invest it for at least 10 years. Isla's invests her money in an account Rapid Blank that offers 5% simple interest annually. Brianna says it is better to invest in an account that offers compound interest because it grows quicker. So she's in an account for QuickBank that offers 3.5% interest compounded annually. Cindy is not sure which offer is best, so she invests $100 with Rapid Bank and $100 with QuickBank. Answer the following questions, giving your answers to the nearest zero. AA. Evaluate how much each investment is worth after 10 years. Okay, this one's simple if you know what simple interest, compound interest, and well, Cindy just did both are. Simple interest is given by the formula A is equal to P, which is your original amount that they were given, times 1 plus RT. T is time, and R is how much the bank is actually offering in simple interest. So we'll do Aya's amount first. Aya's money is going to be equal to 200 or starting times 1 plus 0.05. And that is equal to 5%, by the way. I should say that times 10, which is going to be equal to the 10 years that we have. Doing the math, you get that this is equal to 300 euros. So that's how much she has. Next is Brianna. Brianna has decided to do compound interest at 3.5% yearly. Brianna's equation is a bit more simpler. It's just going to be what looks to be a geometric sequence here. So 200, her original amount, times 1.035, which splitting this up is just 1 plus 0.035 for the 3.5% annually she has. To the power of 10 for the amount of years, which rounding you get around 282.12. And last is Miss Sydney over here who thinks she's smart. She might be, actually. She might be making the most money. Who knows? We'll see. So she does half-half. So she invests 100 in simple interest. So 1 plus 0.05 times 10 plus 100 in compound interest, 10. And this gets her $291.06. Okay. And that is our answers for all three of them. Looks like Isla's making the most money so far, but we need to see how much they make at an even longer period. 8B is asking us how much each investment is worth after 25 years. This is all just busy work and I hate it. But let's get to calculating. A for Alia is going to be equal to the 200 she invested times 1 plus 0.05, yep, 0.05 times 25 now, which is equal to 450. Looks like she's having a drop off going on. She might have to do something about that, so I want to be happy. And Brianna is going to be the one with compound interest, which is just given by the formula from earlier. That's going to be equal to 472.65. She's actually making bank now. And oh, Sydney, the half-half girl, is going to be equal to 100 times the simple interest plus 100 in compound interest. That's supposed to be a 1. And that's equal to 461.65. Congrats, she's in second now. But Brianna's beating everyone. So let's go to 8C. 8C asks us to determine how many years the three investments yield approximately the same amount. Okay, so here we're just gonna have to set them all equal to each other basically. And we don't need to include Cindy in this sense, hers considers both of them. So when you consider the fact that if they're both equal, or if what were their names? Alia's and Brianna's are both equal or are equal at the same time, that means so is Cindy because she's just using both of them at the same exact amounts. So we set up the equation here. And we don't actually know how many years, so I'm just going to count that as n for now. Is equal to 200.035 to the n. N is just going to be equal to years here, by the way. I probably should have done t for it, but it's fine. The 200s cancel out when you divide. So then you're left with 1 plus 0.05 n is equal to 1.035 n. Now, there's no like real way to actually do this without getting a calculator, but once you get a calculator, you get n to be equal to around 20.535. Now, I'm assuming these are all just going to be like actual integers that are years, so this rounds up to 21, so it takes around 21 years. That's what I'm assuming. It could just literally want this, but I don't see how that makes sense. So we'll just go on to 9. At the start of 2010, Kareem had $5,000 to invest. He decided to invest part of the money in a savings account that offered 1.5 simple interest per year. He had $1,000 of this amount and fixed it for 10 years in bonds that offered 2.5% compound interest per year. The rest of the money he invested in shares. Okay, so we have all that information. 9A is now asking us that after 1 year, the money invested in the shares made a loss of 1%. Given that the total amount of money invested increased by 75%, determine how much money Kareem invested in each. Now, let's have S be the amount in the savings account at the start. So S is going to be equal to who knows what. We don't actually know yet. We'll just do $sign. And we're going to have B equal to S plus 1,000 because as the equation said, his bonds were just the amount that he added to the simple plus 1,000. And then the remainder of this goes to his shares. So let's say that we can't use S for the shares again. Dang it. Okay, we'll just use R. That's going to be equal to 5,000, which is the total he had, minus S minus B. And we know B is just going to be equal to S plus 1,000. Which means that the amount in shares is 4,000. Whoa, whoa, whoa. Sorry. Yeah. Okay. That's supposed to be a minus sign. As long as when you forget to multiply. 4,000 minus 2s. Okay. Now it tells us that after 1 year after 1 year, his savings account earns simple interest of 1.5%. So we can make, oh, geez, I'm slipping up all my own words. Okay. After 1 year, savings earn simple 1.5%, which means that the bonds, yeah, just write it down here, savings 0.015%. Well, the amount of savings he had originally. Bonds is going to be a 2.5% compound, which means that he'll have 0.25% bonds more. But his shares, which is R in this case, actually lost money, so he'll have a negative 0.01 R that's added onto his shares. And the total net was 75. Okay, now that we have all this, we can set up an equation with everything. we know if these are all basically just like the change he had left from everything, we can set up that. Oh, let me zoom in. Oh, no, no, what's going on? You can say that 0.015 of his shares plus 0.025 of his bonds. Oh, these are his savings, sorry. Minus, because he actually lost money, 0.01% of his shares is equal to 75. So look at that, we actually have an equation going on. Let's substitute bonds, which is equal to S plus 1,000. We're going to convert all these into his savings. And R, which is going to be equal to 4,000 minus 2S. So now we have 0.015 savings plus 0.25 bonds minus 0.01 4,000. Oh my God, this is horrible. I shouldn't be complaining this bad. I'm supposed to be teaching. Okay, but after simplifying all of this, we end up getting this equation. Oh, whoops, let me go back. It's supposed to be 0.025 S plus 40 minus, oh, what was that? I'm messing up again. Plus 25 minus 40 plus, that's a negative 2s right there, plus 0.02s, which is equal to 75. Yeah, combine the like terms, combine the constants and everything, you get 0.06s plus, oh, that's not a plus, minus 15 is equal to 75. Doing the math, you get that S is going to be equal to 1,500. And that is how much he invested into the savings account. From there, we can do all the equations. Bonds is going to be plus 1,000 debt, which is 2,500. And then his shares, which is just R right now, is going to be 4,000 minus twice of his sharings. His savings. So it's equal to 1,000. Boom. There we go. Kareem invested 1,500 in savings, 2,500 in bonds, and 1,000 in shares. That is our answer. That was horrible. Okay, at 9B, scroll down, start again. I said this earlier, but this video is going to be rough. At the end of the first year, Kareem decided to sell the shares at their current value and reinvest the money in his savings account. Evaluate the total value of his investment at the end of 2020. Okay, that's around 10 years later. So let's get started. All we have to do right now is just basically plug everything back into like all the equations and whatnot. It's saying you decided to sell shares at their current value and reinvest them into a savings account. Okay, so let's not worry about the savings and shares right now. We know he didn't touch the bonds, so he still has 2,500 in those bonds. And since it has been 10 years, we're going to multiply that by the compound interest it gives them, which is equal to around $3,200.21. Okay, that's that for bonds. Now a savings route. Savings. He said that he sold all the shares and put them into savings. Um, his initial savings was 1,500, and as this is going to be multiplied by 1 year, remember, because this is after that year occurred. They realized that, oh, these shares aren't working so well. So let me sell these shares and just put them back. To actually add whatever amount he had for his shares here, you have to find out how much money he had after he lost 1% of his shares. He started with $1,000 in shares, but then he lost 1%. So now he has $990 in shares. So that means that the amount of money he will now invest in his savings is equal to 20,512 and 50 cents. And let's find out what that equals after 25 years. So get the amount of value that we have, 2,512, 50 cents, multiplied by 10 years. Remember, this little equation originally looked like this. Now it's plus 10 years of time. Oh, that's going to be times. Oh, wait, no, what am I talking about? Sorry. Equation for simple interest is going to look like this. Times the amount of years, which is 10. That means it's going to be 2,512.50 times 1.15, which is equal to $2,889.38. And now we add these two numbers together, and we end up getting $6,089 or $6,089.59. That is how much he made after this 10 years, after doing his little method. Confusing method, but if it works, it works. Okay, and 9C actually gets a bit more simpler. It's asking what if he had divided the money up equally, his $5,000 up between the savings account and the bonds at the very start. So now we can finally just get rid of his shares, and we can do the math. 5,000 divided by 2 is 2,500. So in his savings, he would have started with 2,500, and this is over the span of 10 years once again, by the way. 1 plus 0.015 times 10, which is equal to 2,875, and then 2,500 for his bonds, compound interest, 0.025 times 10, which is going to be equal to around $3,200.21. Adding these together, you get $6,075.21. But we're not done yet. It's asking us to compare and see. Is it asking us to compare? Yeah, how much more money he would have made if he just divided them up evenly. And he actually doesn't end up making more money during the subtraction here. He gets 6,089.59 minus 6,075.21, and that's $14.38. So his original parent gave him more money. That's the answer to that. Oh my God. One problem left. Thank God. I'll say this is my least favorite unit, but well, it is one of the harder units just because of how confusing it can be. A pharmaceutical company has developed a drug that fights a bacterial infection. The drug is to be administered 4 times per day, every 6 hours. It was found that 6 hours after administering it, 37.5% of the original amount was still in the bloodstream. The maximum safe level of the drug in the bloodstream is 8 milligrams per milliliter. So 10A is asking us to construct a model that represents the amount of drug in the bloodstream at the end of the day 1, and then immediately after the 4th administration. So we're going to let R, since this is a geometric equation, be equal to 37.5%, which is equal to 0.375. That's how much amount of drug is actually going to be, what was it? Yeah, it's how much amount of drug is still going to be remaining at any interval of 6 hours. And we know that each dose is given, we know that each dose is given every 6 hours, and then immediately after dose, we look at the bloodstream. Okay, after the first dose, the blood has D amount, and D is just going to be the full antidote here, basically. After the second dose, it's going to have D amount times R plus D. This is the second dose, and that is the original first dose. After 3 doses, it's going to be D plus dr plus dr squared. This is our third dose. This is our second dose, and that's getting multiplied by r because it's been after that. And this was our first dose, or oh my god, our first dose. And then after the fourth dose, you know how that's going to be d plus dr squared plus dr cubed. So that gets us the equation that the entire value of this blood is going to be, or the amount of medicine left after 4 doses is going to be D, the original amount, plus all the rest of these ratios. And remember, this is literally just equal to this. I just took out the D from the summation over here. And we know that this is going to be equal to 1 minus r to the fourth over 1 minus r. And so our 4 terms, that's all getting multiplied by D. So the amount is, that's going to be left immediately after, it's asking right after the fourth administration. Oh, no, it's just asking us to construct a model. Okay, so it's not actually asking us to solve, but this is when R is equal to 0.0375. If it is asking to solve and I just misread it, just plug R in and that's your answer. Okay. 10b. The company advises that the drug should not be administered for more than 10 days. Evaluate the maximum amount that should be administered to ensure that the amount of drug in the blood stream does not exceed the safety level. Okay. We know from earlier that the safety level is 8 milligrams per milliliter. Check the math equation for this. We need to find out first how many doses are going to be taken over the next 4 days. Or no, it's 10 days. And it's going to be multiplied by 4 doses for each day. So we know there's going to be 40 doses done over the days. We must make sure that the highest doses, or the dosage, the summation of all of these does not exceed 8 milligrams. So let's set up an equation. The amount of drug left in his bloodstream is going to be equal to D, which is the original amount of drug put in him, and then 1 minus ratio divided by N, 1 minus R. All right. We know that in this case, N is going to be equal to 40 because that's going to be 40 doses. So we know that summation 40 doses has to be less than or equal to 8 for it to be a safe level. Which means that oh, let me put it down here, which means that 8 has to be, whoa, 8 has to be greater than or equal to the amount of drug in his body. And since we're trying to find the amount of drug in his body, or shoot, what am I? Oh no, I'm getting mixed up in my words here. Oh yeah, okay. Evaluate the maximum amount. So we're trying to evaluate what D is here. So we can just flip these equations around and get D has to be less than or equal to 8 times 1 minus R to the 40 divided by, sorry. 1 minus R divided by 1 minus R to the 40. Because we're trying to find how much um, drugs we're able to put in him before it becomes dangerous. And we know that R is going to be equal to 0.375. So let's just plug this back in. Remember that for any value between -1 and 1 that's getting exponentized to such a great exponent like this can basically just equal 0 in this case. It's astronomically small. It's effectively 1. So that means the maximum amount of drug that can be administered is going to be 8 times 0.625, which is equal to 5. So at one given time, the maximum a single dose can be is 5 milligrams for it to be safe after all of these days. And that is our answer. That's B? Yep, that was B. Okay. 10C. The drug starts being effective when the amount of drug in the bloodstream is 7 milligrams. Determine how many times the drug must be administered for this level to be reached. Okay, pretty simple. We already know that the amount of milligrams that are going to be administered in one drug for it to be safe is 5 milligrams. And we know it becomes effective at 7 milligrams. Okay. We're just going to use our summation equation from last time. And we need to find out when this is greater than or equal to 7. Sorry, no. That's 5 minus 0.375 and 1 minus 0.375. And then after doing the math here, you get a pretty wild equation. But n actually ends up rounding to just 3 here. You can't, administer like 3-point blank of a drug. So we know it's just going to be equal to 3. If you want to check this, you can always just plug in n equals 1, 2, 3, so on and so forth until you get an actual answer. I wouldn't recommend doing that because imagining a number is huge, it'll just take forever. This is the way, just plug it into a calculator, solve, and then round it to whichever number is the nearest. But yeah, that's gonna be all for today. Sorry this video was kind of rough. Could have been better, definitely. But I hope to see you all next time, and I hope any answers got solved. Oh, look at that. We have a little pattern going on, right? Just completely angled down.